Here we go. So this is a little bit different from what we've talked about up to this point. This is something that you've seen before. There's no such thing as a free lunch in the universe. So mass is neither created nor destroyed. That means that you can't get something from nothing. So if someone's telling you that they've created a miracle engine, I would be dubious. I would not accept that. If you talk to engineers, engines notoriously lose effectiveness, and they only put out a percentage of what they actually take in. So you're going to notice that conservation of mass, we're talking about not losing that mass. So what does that mean for chemistry? That means that the mass of the reactants always have to equal the mass of the products. This is a given throughout all of chemistry. You may notice, though, what you started out with, you don't get 100% of product. And the reason why is you're losing it through transfer of material. You may spill things. You may have loss of material because it went into the air. So there's a lot of different things that go on that don't give you 100%. Okay, this is the last calculation that we have to do within this chapter, and this is law of definite proportions. So what does this mean? Well, this essentially means that a compound is always composed of the same elements and in the same proportion, okay? So if I have a bottle of water, okay, there's going to be 2 hydrogen for every oxygen, no matter how much water I have. So that means for water, and it could be water here, it could be water in California, it could be here, water in Australia. Each sample of water has the same proportion of hydrogen to oxygen. And notice that it's the ratio of mass of one element to another. And it's just a real simple calculation that you have to do. So each element to the total mass. So you take the mass of the individual element and you divide it by the total mass of the compound. And notice that you multiply it by 100, and we'll do a couple examples of that. Okay, so water is 88.9% by mass oxygen and 11.1. Now, even though there's 2 hydrogens, those 2 hydrogens are very small in mass. Oxygen actually has a greater mass than than hydrogen. Okay, here we have rust, and rust contains 70% iron and 30% oxygen. So notice that iron is very large compared to oxygen, and that makes sense because it's further on in the periodic table. Okay, here we go. So this is our first calculation. So we have 84 grams of copper and 16 grams of oxygen, and they want to know what is the mass percent of each component. So what we're essentially going to do is we're going to add up the 2 of them. So 84.0, and yes, we're paying attention to sig figs, plus 16.0 grams equals 100. And then after you've calculated the total mass of each, you're essentially just going to take it, divide it by 100, and multiply it by 100. Okay, so the first percentage is essentially 84. And then the second percentage will be 16, because when you take 16 divided by 100 times 100, that gives you 16%. Another shortcut would be just to take 100 minus 84, and that'll give you the same value. Okay, and I'll let you do number 4. So go ahead and do number 4 on your own and see what happens. Okay, this is the last section. This is separating mixtures. Now notice that filtration, this is something that you'll probably be more familiar with in the lab because you're separating a solid from a liquid with a barrier. Okay, so in the lab you're going to find that you have a solid suspended in a liquid and you want to remove the liquid and just be left with the solid. You're essentially taking filter paper and putting it in a funnel, and then you're going to remove the water and keep the solid. Distillation, so this is something that is more appropriate for advanced techniques. You're essentially boiling a solution and you need to have a still, and the higher boiling material tends to be left behind while the lower boiling material gets condensed and removed. And when you drink or use distilled water, that's essentially what they've done, is they've removed the lower boiling point materials and you're left with just water. Crystallization, you may be doing that in one of your chemistry labs, and essentially you're just waiting for the solid to come out of solution and you're left with a liquid. And then lastly, sublimation. This is definitely an advanced technique. So you're essentially taking a solid and making it into a gas, and whatever you want is left behind, and whatever you don't want is separated out from the combination. Okay, so this last section here, we're talking about separating out using chemical means, but notice that the elements can never be separated. So there's no way that you can make the elements smaller by chemical means. However, you can use compounds and you can break them into components by chemistry. So here on the right we have a battery, and the battery is actually connected to a couple catalysts that happen to be platinum, and we're taking acidified water and we're essentially separating it out into oxygen and hydrogen. By the way, these are diatomics. So if you look at the last section of this, we have matter at the top. Oops, sorry about that. So matter at the top, and then you have two types of situations here. So you have either mixtures or you have pure substances. Now please notice that the only way that you can separate them out is through physical changes. But however, under mixtures we have what we call heterogeneous. So remember, they're not the same throughout. If you take a cross section, you're not going to see a uniform substance. You could have a homogeneous mixture. Remember that tends to be solutions. It has to be the same throughout. If you take a cross section, you're not going to see anything different. And then on the right here, for pure substances, okay, we could have elements. So elements would be by themselves. There's nothing else but the element. It could be a diatomic molecule, or it could be an atom bonded to itself. Lastly, there's compounds. So compounds would be something like what we talked about the other video. We talked about salt, we talked about sugar. I used baking soda today. So those are examples of pure substances that are compounds.